Today we're going to look at an extension lesson from 3.2, and this one is called factoring expressions. When factoring an expression, you write the expression as a product of factors. Remember, a product is the answer of a multiplication problem. Factor times factor equals product. And then you can use the distributive property to factor the expressions. So I like to factor out expressions a little bit different than the way that they have it set up here. Well, for the first part, factoring out the GCF. So there's different ways of finding the GCF. One way would be to make a factor tree and circle the common factors and then multiply the common factors to find the GCF. Or we could use something that we call the ladder method. So we're going to start with the factor tree, and I'll show you the ladder method as well, and then I'll show you what to do with the GCF and how to factor it out of the expression. So over here, we're going to do our factor trees for 24 and 18, since those are the numbers in the expression. So you do 24 at the top and 18 at the top. And when we're making a factor tree, we're trying to say to ourselves, what two numbers can you multiply together to get 24? And there's more than one answer. However, when I'm doing it, I always like to use a prime number on my left so that I can circle it and that branch will end, and then you can keep going off of the right side. So 24, I always start with the first prime number that there is, which is 2. Does 2 go into 24? Yes, it does. So I would do 2. 2 times what is 24? 2 times 12 is 24. 2 is prime, I circle it. 12 is composite, I need to keep going. It has more factors than 1 in itself. What's the first prime number that can go into 12? 2 again. 2 times what is 12? 6. Circle the 2 because it's prime. Factor off of the 6 because it's composite. What goes into 6? 2 again, times 3 is 6. So my factors here are 2 times 2 times 2 times 3. And why did I circle the 3? Because 3 is prime. Its only factors are 1 in itself. So as soon as you have two prime numbers at the end, you know that you are done. You can check it. 2 times 2 is 4, 4 times 2 is 8, and 8 times 3 is 24, which takes us back to the top. I do the same thing with 18. First prime number to go into 18 would be 2. 2 times 9 is 18. What's the first prime number that can go into 9? 2 does not. The next prime number would be 3. 3 goes into 9 how many times? 3. 3 times 3 is 9, both of which are prime. So its factors are 2 times 3 times 3. Check it. 2 times 3 is 6, and 6 times 3 is 18. Now we're going to look at which ones do they actually have in common. Well, they have this 2 in common, and they have 1, 3 in common. So they have a 2 in common and a 3 in common. We're going to multiply those, therefore the GCF is 6. All right, so prime factorization, factor trees is one way of doing it. Or the next way of doing it is our ladder method. So with the ladder method, we're going to write the two numbers up top, 18 and 24, and we're going to draw a little ladder. So we're going to say, what can go into both 18 and 24 evenly? Well, they're both even, so they are both divisible by 2. 2 goes into 18 9 times. 2 goes into 24 12 times. And then we're going to keep going. Is there another number that can go into 9 and 12 now? What goes into 9 and 12? 3 does. 9 divided by 3 is 3, and 12 divided by 3 is 4. Is there a number that can go into 3 and 4 evenly? No, only 1. So that means that we are done. We can put the 1s down here since we're done. And we're going to multiply everything out here in our ladder. 2 times 3 times 1 times 1 is still 6. So again, GCF for 6. And so the ladder method is just another way of doing it. And what you're doing is you're finding what is divisible into both numbers. You put what's divisible on the outside and you divide. If there's something else divisible, you put it on the outside again and divide again. And you do that until there's nothing divisible except for 1, and then you can bring those 1s down so that you can see here's the L shape here, the ladder method. That's what you're multiplying together. So now that we know that 6 is the GCF, they want us to use that GCF to factor the expression. So in order to do that, I'm going to rewrite the problem down here. 24x minus 18 is what we are factoring. So since we're factoring out 6, 6 is going to be the first factor. So it's going to be 6 times some number that should take me back to 24x minus 18. And all you have to do is you take that expression and you divide by what you're factoring out. So we're going to divide by 6 because that's our first factor. 24x divided by 6, well, 24 divided by 6 is 4, and we would just bring our x down. Negative 18 divided by 6 is negative 3, so minus 3. So 6 is our first factor, and the answer to this division problem is our second factor. Then we can check it. We're going to check it by distributing. If I distribute the 6 to each number inside the parentheses, it should take me back to the original expression. 6 times 4x would be 24x. 6 times a negative 3 is a negative 18. And you can see that this matches the original one, so we're good. So once you know what the GCF is, your GCF is your first factor. Your second factor, what's inside parentheses, comes from dividing the expression by the GCF to get what goes inside the parentheses. Let's look at another one. In this one, they're just telling me to factor out 1/2. Not the GCF, but 1/2. That's what they want me to factor out. Therefore, 1/2 will be my first factor. Draw my parentheses. My second factor is going to come from me dividing the expression. I'm going to write it over here. 1/2 x plus 3 over 2 has to be divided by 1/2. 1/2 x divided by 1/2, anything divided by itself is 1, so we're left with 1x. Or if you just want to write x, that's fine as well. 3 over 2 divided by 1/2 leaves me with a positive 3. You can check that in your calculator. So the answer to my division, the answer to me dividing this over here, goes inside my parentheses, and it is my second factor. Factor times factor equals product. I'm going to use the distributive property to check. All right, so we're going to factor out that 1/2. 1/2, and I'm going to write this one as just x plus 3. Remember, I said you don't need to write that 1. So we've got 1/2 times x. That would give me 1/2 x. And 1/2 times 3 is a positive 1 and 1/2. Now look, does that match the original one? I see the 1/2 x plus 3 over 2, and here I have plus 1 and 1/2. Well, 3 over 2 is equivalent to 1 and 1/2. 3 over 2 is an improper fraction. 2 can go into 3 one time with 1 left over. 1 and 1/2. 1/2 as a decimal is 1.5. So you can see that they are the same, just written differently, but they are equivalent numbers. So 1/2 times 1x plus 3 would be my factors if I had to factor out 1/2. Let's look at another one. Now we're factoring out a negative number. So they're asking me to factor out negative 2. Therefore, negative 2 is going to be my first factor. I'm going to take my whole expression, negative 4p plus 10, and I'm going to divide it by the negative 2. My answer to my division problem goes inside my parentheses. A negative 4p divided by a negative 2, remember a negative divided by a negative is a positive, so that's going to give me a positive 2p. And then a positive 10 divided by a negative 2 would give me a negative 5. I'm going to use the distributive property to check it. Negative 2 times 2p minus 5. We are going to distribute that negative 2 and make sure it takes us back to the original expression. Negative 2 times positive 2 is a negative 4p. Negative 2 times a negative 5 is a positive 10. And we can see that this matches that, so we know we are correct. Negative 4p plus 10 was my original one. Therefore, negative 2 times 2p minus 5 would be my two factors. So we have a lot of practice problems here. I'm going to do some of them with you before I set you off on your own. in the first couple, they're just numbers. There's no variables. So that doesn't change the process that we're going to do. I'm going to rewrite number 1 down here. I'm going to use this one up here, but I'm going to come down here with my answer. So factor up using the GCF. So remember, we can do our factor trees to find the GCF, or we could do the ladder method. Or you could even find the GCF in your calculator if you have a TI-73 using your math button, and we'll teach you that in class. So 9 and 21, if I want to do the ladder method, I could do 9 and 21. Oops. What do 9 and 21 have in common? What can go into 9 and 21? 3 does, so I can write my 3 out here. 9 divided by 3 is 3. 21 divided by 3 is 7. Do 3 and 7 have anything in common? Nope. So we can bring down the 1, close off our ladder, our L. 3 times 1 times 1 gives me 3. And 3 would be the GCF of 9 and 21. It's the highest number that they have in common, which means we're going to take the entire expression and divide it by 3. And we know that 3 is going to be our first factor because that's the GCF. 9 divided by 3 is 3. 21 divided by 3 is a positive 7. They are your factors. Do you want to check them? Distribute. 3 times 3 is 9. 3 times 7 plus 21 takes you back to the original. If I do number 5 with you, I'm looking at what do 20 and 8 have in common. So we could do the ladder method again. Since that's something new, that's what I'm going to keep using. 20 and 8. What can go into 20 and 8 evenly? Well, I know that 20 and 8 are both divisible by 4. 20 divided by 4 is 5, and 8 divided by 4 is 2. Is there anything that can go into 5 and 2 evenly? Nope, nothing goes into 5 and 2. Therefore, we bring down the 1s, and we can multiply out. 4 times 1 is just 4. So we are going to divide everything by 4, which is our GCF. So number 5 down here, we know that 4 is going to be our first factor. And the answer to the division will go inside my parentheses. 20z divided by 4 would be a 5z. Negative 8 divided by 4 would be a negative 2. And you always want to distribute to check. 4 times 5z would give me 20z. And 4 times negative 2 would give me a negative 8. And that matches your original, so you're good. I'm going to do another one with you as well. Let's do number 6. 15 and 65. I'm going to do another ladder method for you. What can go into 15 and 65 evenly? Well, they both end in a 5, therefore they have to be divisible by 5. 15 divided by 5 would be 3. 65 divided by 5 would be 13. Does anything go into 3 and 13 evenly? Nope, so we bring down 1s. Multiply everything inside your L. 1 times 1 times 5 would just be 5. So we have a GCF of 5 in number 6. Number 6 here. So we know that 5 is our first factor. 15w divided by 5 would be 3w. And 65 divided by 5 is 13. Distribute to check. 15w and a positive 65. All right, I'm going to ask that you just do 2, 3, 4, 7, and 8, then come back and we'll do some more together after that. So pause the video, just finish under the first set of directions up to number 8, then come back and check your work. All right, so let's go to number 2 here. Number 2 doesn't have any variables, but like I said, that doesn't change what we're doing. 32 and 48 using my ladder method. What can go into 32 and 48 evenly? Well, I know that they're both divisible by 2, so if you want to start there, we'll see a long ladder. 32 divided by 2 is 16. 48 divided by 2 is 24. Go to the next wrong. What can go into 16 and 24 evenly? Well, both of those are divisible by 8. So let's try 8. 8 goes into 16 2 times, and 8 goes into 24 3 times. Does anything go into 2 and 3 evenly? Nope, so we bring down 1s and multiply everything in there. 2 times 8 times 1 times 1 would give me, what did I just do wrong? Sorry, we didn't do anything wrong. 2 times 8 is 16 times 1 times 1 is 16. So 16 is the GCF of 32 and 48. All right, so we know we're going to use 16. So I'm going to erase that so we can see the problem. Therefore, we're going to divide the entire thing by 16. And we know that in number 2, 16 is our first factor. 32 divided by 16 gives me 2. Negative 48 divided by 16 gives me a negative 3. And then we could distribute to check it. 16 times 2 is 32. And 16 times a negative 3 would be a negative 48. Done. In number 3, 8x plus 2. So I want to use the ladder method for 8 and 2. What can go into 8 and 2 evenly? 2 can. 8 divided by 2 is 4. 2 divided by 2 is 1. Does anything go into 4 and 1 evenly? Nope, just 1. Bring them down. Close your ladder and multiply. 2 times 1 times 1 gives me a GCF of 2. So for number 3, your first factor is 2. And we're going to divide to get the factor that goes inside our parentheses. 8x divided by 2 would be a 4x. And 2 divided by 2 would be a positive 1. And then we're going to go back and distribute to check again. 2 times 4x is 8x. 2 times 1, positive 2. And that matches my original expression. In number 4, 3 and 24. What can go into 3 and 24 evenly? 3 does. 3 divided by 3 is 1. 24 divided by 3 is 8. What can go into 8 and 1 evenly? Nothing. Bring down our 1s. Multiply. We got a GCF of 3. 3 being our first factor. We're going to divide everything by 3. 3y divided by 3 would leave me with just a y. Negative 24 divided by 3 would leave me with a negative 8. Distributing to check. 3 times y is 3y. And 3 times negative 8, negative 24. Matches my original expression. Sorry. All right, then we can move on to number 7. We're looking for the GCF of 36 and 16. What can go into 36 and 16 evenly? I noticed that 4 goes into both of them. 36 divided by 4 is 9, and 16 divided by 4 is 4. Is there anything that can go into 9 and 4 evenly? Nope, nothing goes into them. Bring down your 1s and multiply your ladder. That would leave me with 4 as my GCF, making 4 my first factor. 36a divided by 4 would be a 9a. And 16b divided by 4 would be a positive 4b. Just like always, we are going to distribute to check. 4 times 9a would be a 36a. And 4 times 4b would be a positive 16b. And that matches my original expression, so we're good. And then the last one like that, in number 8, we're going to look for the GCF of 21 and 49. So if I write them up here, 21 and 49. What can go into 21 and 49 evenly? They're both divisible by 7. 21 divided by 7 gives me 3. 49 divided by 7 is 7. What can go into 3 and 7 evenly? Nothing. So we're going to bring down our 1s, close off our ladders, and multiply, and that gives me 7. So we know 7 is the GCF of 21 and 49. Therefore, in number 8, 7 is your first factor. 21m divided by 7 would give me a 3m. And negative 49n divided by 7 would give me a negative 7n. Distribute to check. 7 times 3n, is 21m. And 7 times a negative 7n would be a negative 49n. Go back up here and check, and they match, so we're good. All right, we're then going to move on to the second set of directions, which is asking you to not factor out the GCF now, but factor out the coefficient. So if we remember from the beginning of the chapter, a coefficient is a number that's attached to the variable. So in number 9, the coefficient, I'm going to look for the variable, which I see is b. What's attached to that b? 1/3 is. Therefore, we're going to look at 1/3 as the coefficient. And since 1/3 is the coefficient, 1/3 is going to be my first factor, and I'm going to divide this entire expression by 1/3 to get my second factor. 1/3 b divided by 1/3 would leave me with just b. Negative 1/3 divided by positive 1/3 would leave me with a negative 1. And just like always, we're going to go back and distribute to check. 1/3 times b would be 1/3 b, and 1/3 times a negative 1 would give me a negative 1/3, and I can see that that matches my original expression. So remember, you're going to factor out the coefficient, the number that is attached to the variable. 1/3 here is attached to b, so we knew to factor out the 1/3. See if you can do 10, 11, and 12, factoring out your coefficient. Pause the video, then come back and check your answers. So in number 10, what's attached to the variable d? 3/8 is. Therefore, we're going to factor out 3/8. And in number 10, 3/8 will be our first factor. We're going to divide everything by 3/8 to figure out our second factor. 3/8 is d divided by 3/8. Anything divided by itself is 1, so we're left with just 1d, or simply d. And 3/4 divided by 3/8, you plug that into your calculator and you get 2 plus 2. Multiply to check. 3/8 times d is 3/8 d. Excuse me, and 3/8 times 2 takes me back to a positive 3/4, and our expressions match, so we did it correctly. In number 11, what is attached to my variable? 2 2/10 is attached to x, therefore we are going to factor out 2 2/10, and therefore in number 11, 2 2/10 will be my first factor. Divide everything by 2 2/10 to get your second factor. 2 2/10 x divided by 2 2/10. Anything divided by itself is 1, leaving us with x. And 4 4/10 divided by 2 2/10 would leave me with a positive 2. Multiplying to check. 2 2/10 times x would be 2 2/10 x. 2 2/10 times positive 2 would be a positive 4 4/10. In number 12, what is attached to the variable? 4 is attached to the h, therefore we are going to factor out 4 in number 12, and 4 will be our first factor. 4h divided by 4 would leave me with h. Negative 3 divided by 4 would leave me with a negative 3/4. Multiplying out to check. 4 times h is 4h. 4 times negative 3/4 gives me a negative 3. That matches my original expression, therefore I am done. So 13 and 14 are the same process, except now they're telling you exactly what number to factor out. They don't want you to factor out a GCF. They don't want you to factor out a coefficient. They're telling you exactly what to factor out. So in number 13, they're asking us to factor negative 1/2 out of that expression. I'm going to rewrite the expression down here. So I've got negative 1/2 x plus 6, and they want me to factor out the negative 1/2. Therefore, I'm going to divide everything by negative 1/2, and negative 1/2 is going to be my first factor. Negative 1/2 x divided by negative 1/2 will leave me with a positive x, because a negative divided by negative is a positive. Positive 6 divided by a negative 1/2 would leave me with a negative 12. There's my two factors. Then I want you to distribute to check. Negative 1/2 times x is negative 1/2 x. Negative 1/2 times a negative 12 would be a positive 6, which takes us back to the original expression. So right now I want you to try number 14 on your own. Number 14 is asking you to factor out a negative 1/4. If you can't see your expression, which you showed it's on your paper, you've got negative 1/2 x minus 5/4 y. Factor out your negative 1/4, pause the video, and then come back and check your answer. All right, so since we're factoring out negative 1/4, we're going to be dividing everything by negative 1/4, and we know that negative 1/4 is going to be our first factor. Negative 1/2 x divided by a negative 1/4, a negative divided by a negative gives me a positive 2x, and a negative 5/4 y divided by a negative 1/4 would leave me with a positive 5. And like always, we will distribute to check. Negative 1/4 times 2x is a negative 1/2 x, and a negative 1/4 times a positive 5 is a negative 5/4, or if you did it in your calculator, oh, we forgot something, my bad. What did we forget here? And the only reason I caught it was because I was checking it. I should end up with a y here. So when we divided negative 5/4 y divided by negative 1/4, that should have been a 5y. See how it's so important to go back and check your work. So now I would have recognized negative 1/4 times a positive 5y. That's where I'm going to get that y that I need. And remember, 5/4 is equivalent to 1 1/4, or 1 25/100, if those were the numbers that you got in your calculator. They are equivalent, so the answer is still correct.